and talk a little bit about OOP in Ruby. And I think it's easiest in this case to just walk through an example of how you do simple classes in inheritance. So we're going to define a new class. It's going to be for a bank savings account, and it inherits from account. That's what the less than notation means. The constructor has to be called initialize. It's just one of those things. Get used to it. Even though the way you call it, as we'll see, is with new, it's got to be called initialize. It's an idiosyncrasy. Sorry about that. You can pass the constructor any arguments you want, and in it we're going to set this instance variable. Notice the @ sign. It means I am an instance variable. All right? That is a syntactic thing. OK, why do we need an instance method whose sole purpose in life is to return the instance variable? It is because in Ruby, the encapsulation of objects is total. When you declare an instance variable, like @balance, it is absolutely invisible anywhere outside the instance of the object that owns it. Anywhere outside of that, even in the same class. So the only access to this instance variable from outside of the object is by defining a getter method, as Java calls it. So some people also call it an accessor method. And similarly, we have to define a setter or a mutator method, because the only way to set the value of the variable from outside the object is to call a method. Notice that balance equals is a legitimate method name. Okay, method names ending in equal are special. It means I am a setter method. This is the only way to set the variable's value from outside the instance that owns it. We can deposit stuff into our bank account just by increasing balance. Okay, notice that inside this method, we can access @balance because we're still inside the object whose instance methods these are. What about, excuse me, what about class variables? Double @ sign is what Java would call a static variable. It means there's one value for all instances of the class. They can all access it. They can all change it. They all see the same value. And we can define class methods, which Java calls static methods, by preceding the method definition with self. Now, as an aside, and kind of as a preview, don't worry if this makes your brain hurt a little bit. If it seems arbitrary that that class method names begin with self, what's the value of self here? Well, as it turns out, when I said everything is an object in Ruby, I really meant it. Okay, even a class is an object. In fact, a class is an instance. Ready? A class is an instance of the class with a capital C. Okay? Don't worry about that too much, but it's basically my way of saying at least the language is internally consistent. When you say class savings account, this is not a declaration in the Java sense. There is a method called class that is getting executed and is actually adding all this code at runtime to define the methods on your class. And within the scope of this class non-declaration, the value of self is the class object that is being created. So once you realize that, it makes a lot of sense that self.bankname is a class method. It's defined on the object, which is the class called savings account that we're in the middle of defining. And what are we going to do in this instance method? We're just going to return the value of the class variable, because again, it's invisible outside the class. And there's, if you could hold your questions for just a couple of slides, that'd be great. OK, and I actually have this in Pastebin because we're going to play around with it a little bit. There it is. One-click copy and paste. I hope you've all been doing this because the one-click copy and paste is super cool. OK, so now we're going to use that to do a few simple tricks just a few minutes down the road. I could also, by the way, define this class method instead of self.bankname. I could have said def savings account.bankname. Again, once I've started defining things in this class, really what's happened is Ruby has created a new constant, savings account, which is the class object. So I could just as well say this is a method that's defined on that object whose name is that constant. Again, don't worry about it too much. In like a week, this will be super clear. For now, just kind of look, absorb, remember. OK, now, you would think that given that instance variables are so popular, there'd be a shortcut where you say, gee, you know, I want this simple instance variable. You mean I have to just define these trivial accessor methods and setter methods just so that I can get access to it from the outside world? You could do that. Or, ready? Let's see that again. You could do that. Or you could do that. Clearly much nicer and much drier. Now, what's going on here? At your accessor, again, is, like so many other things we've seen, not part of the language. It is just a plain old regular method that uses metaprogramming, programming at runtime, defining new code at runtime, to create those methods for you on the fly. Right? It's basically taking the thing that you pass, the symbol balance, and it's using that as a template to define these methods on the fly and provide them for you. So it really is, in that sense, just saving you some typing and a fair amount of readability. But there's no magic in this, right? It is just a regular method that you could write yourself. In fact, for homework 1, you will do so. In fact, you'll improve upon it. OK. So with that in mind, here's where we are so far. Ruby is object-oriented, and there's no multiple inheritance. There's a far cooler thing than multiple inheritance, which we're going to meet shortly, called a mix-in. Everything is an object, and the only way you get things done is by calling methods on those objects. So class and instance variables are invisible outside the class. You've got to call a method to do anything to them. Everything is a method call. And as we'll see over and over again, I'm going to hammer this, you only care if the receiver responds to the method. Right? This is very different from asking, is the receiver the right class or the right subclass? Most of the time, that is irrelevant. The only question is whether it responds to the method, and we're going to use that to do some really, really nice programming. Most things that look like operators aren't. They're actually instance methods, and they may be defined different ways in different classes. Objects do have types, but the variables that refer to them don't have types. And although the vast majority of methods are not destructive, there are a few that are. Double less than is one example. And there's a few where there's a destructive variant that ends in an exclamation mark. Right? The exclamation mark is a way of warning you that this might be a dangerous method.